The first phase of this project is essentially done, and that is the foundation is in. It's a relief. The footings and the stem wall and the grout, it's nice to have that in, and it feels like it's time to start building, but not quite yet. We have to backfill this. We have to get the bulk of the material back in around this foundation so that once the house is in place, not every spoonful has to be brought in, with wheelbarrows and shovels. We need to do the backfill while we can use a machine. But we can't do that quite yet either, because there's a little more underground work that has to be done. A lot of these final underground utility projects happen simultaneously. But I'm just going to go through them one at a time, and you can make sense of the sequence as you watch this develop. The first item that I want to talk about is the last part of the roof gutter, the rainwater, the roof water collection system. The roof water, it's not enough to get it into gutters and get it down the side of the house and out onto the ground, because then the foundation is saturated by the roof water, and that is not good for anybody. So you need to give some thought to how you're going to transport the water that falls on your roof and ends up in the gutters and comes down the downspouts. How are you going to get that away from the house? In our case, we're laying a 3-inch PVC line on top of the footing. That'll give it enough grade, even though the footing is level. As the pipe fills up, gravity will take it out the end, and it'll take it to the stormwater system at the street, along with the water that's collected in the French drain system that we still have to finish up. We've talked a lot about drainage, because drainage is one of the most important factors that you just have to think about when you're building any kind of a project. Water has to be taken off-site, wherever it comes from. You've got to get it off. So the roof gutter drain system that you're looking at here has got a couple of other little pipes running in alongside of it that have nothing whatsoever to do with drainage. They're chases. Right now they're empty. They're an underground passage that'll remain open so that other utility lines, in this case cable and phone, can be brought in to the property later. Now when I say brought in later, it's something that you can think about. While you're still in the very end of the excavation phase, this is by far the easiest time to put anything underground that's ever going to need to be put underground. Could I come back in with a pick and a shovel and do this later? Yes, but believe me when I tell you I'm tired of digging. So with the equipment on site or coming back, now is the time to get everything underground that you can possibly think of that you will later wish, boy, I wish I had already put that underground. One of the realities of using this big rock for the subgrade, the base, it really is pretty much a base rock. I mean, you could put this under a light-duty road and it would stand up for a long time, because larger rocks in your backfill provide structure. They provide more interlocking surfaces and less tendency to roll, and so the subgrade gets hard. But we won't be able to put either dirt or crushed rock or sand directly on top of this, because the voids between the rock will continue to fill and sort of bleed the fines out of whatever we put on top down in here forever, unless it is protected by filter fabric. So at fine grade time, at concrete time, at the time that we gear up to put the finished surfaces around the house and in the garage and in the front porch, we're going to put a filter fabric over the top of this big crushed, and then go on top of that with whatever we're using to establish the actual elevation of the finished surface. It seems like a little bit of extra work, but it is certainly worthwhile for the benefit of having excellent drainage, excellent compaction, and good clean feet while we're doing the rest of this project. You've seen this temporary power pole on the site before. We've been using it now for, I don't know, maybe a couple of weeks. But there is a long list of specifications about how far from the transformer the temp power needs to be, how far out of the ground the temporary power needs to be, what direction the meter is facing, whether or not the outlets are all-weather, wet condition outlets. All of these things have to pass code and specific power company policies for their convenience moving forward. It matched. We passed. It's in place. And the whole object of temporary power is that it's easy to remove. So here in a while, I don't know how long, when we've switched this project over to permanent power, since the conduit is in place, we'll be able to pull this out of the ground. I'll send it back to Cascade Electric, and we will have outlets in the house. So the last portion of the underground work is to connect the utilities that are under the house, the electrical, the water, and the plumbing, to the services at the street. The sewer line is really the first thing that I need to worry about, because the sewer has to go exactly where the sewer has to go. The stub out from the sewer authority, RUSA, Roseburg Urban Sanitary Authority, comes into a specific location, and it's deep. Down by our retaining wall, it's about 6 feet below the ground, which means I've got lots of slope coming from under the house to make the connection. Almost too much. Once the sewer is completely hooked up with a cleanout in place, by the way, a cleanout is an important thing, put in as many as you reasonably can, it was time for us to call RUSA, the Urban Sanitary Authority, to come out and inspect our connection. By inspect the connection, I mean verify elevations and run a camera down the cleanout out to their main line in the street to make sure that the whole line from the street to our cleanout was sound, would hold what it has to hold, because nobody wants that getting out, and we don't want anything getting into that sewer line except what it is that the sewer line must necessarily transport. So down went the camera, and sure enough, there was a surprise. Turned out to be a benign surprise, but for a day or two, it was anxiety provoking. And it was this: there was a suspicious stain on the top of the pipe down there about 30 feet. About 7 feet underground and 30 feet horizontally, here's this stain on the top side of the pipe that looks like a crack. So the next step, having identified this potentially unpleasant surprise, was to test the line. They came out and did an air test, pressurized the line up to I think 4 or 5 psi. It held for 5 or 10 minutes, I don't remember exactly, but it fit within their criteria to say, nope, no cracks. The fittings are glued, it holds pressure, therefore it will hold water acting under gravity, because it's not a pressure line after all. And so we dodged the bullet. The stain is a stain and not a crack, and the line is sound, and we can move on to the backfill and keep our project moving forward. Water line goes in at the same time. Both of these lines, the sewer and the water, need to be inspected in the trench for depth, for separation between water and sewer, and for the kind of material that is around the pipe. Now, it's an interesting thing about the plumbing line, and that is you don't want it stretched fiddle string tight in a perfectly straight line coming up to your house and up into your building. You want a little bit of slack, or a little bit of you want it to meander just a little bit, so there's some amount of curve in the line, because a water line is a dynamic thing. It's vibrating slightly. It may expand or contract as water temperatures change. It may, if the soil shifts at all, you don't want that thing to crack because it's under tension when there's some amount of movement in the soil. You want a little forgiveness in the distance that your water line travels and in the way it's backfilled, and we're doing that with just a slight bend as it comes from the source, where there's a meter, where there's a valve, into the house where it'll be being put to work. The sewer and the water line, both plastic lines, have a sounding wire put in right alongside or right over the top. In both cases, different wires. Because in the future, somebody is going to want to find these things. And you can't detect a plastic line under the ground unless there's a sounding wire, a conductive wire, laid right alongside. With that in place, you can attach to the sounding wire at either end and then be able to identify exactly where the pipe is in the certain and unpleasant event that someday somebody is going to want to know where that pipe's at. With the water line especially, it's important that the line is bedded. That is, that the dirt, preferably the sand that goes in underneath the line and on top of the line, protects it from contact with rocks. Because like we mentioned, a water line can vibrate and move and shift imperceptibly for a long, long time to come. And that is very likely, if there's a rock in contact with the line, to eventually wear some sort of a hole. A pinhole, but a hole nonetheless. So cover your water lines with sand. In the back of the house, we are putting in the last bit of the French drain system that you've watched us struggle with for, it seems like, a long time. It's the same pipe, it's the same filter fabric, it's the same rock that we used in the French drain that really encircles the entire perimeter of the property. there's not going to be much water that gets past the drainage system that's in place. But if any does get through or under or around the French drain as it exists today, we're going to intercept it before it gets under the house by putting the pipe at the bottom edge of the footing. Once the water's in this pipe, it will be transported by good old gravity and drop straight into the French drain system that already exists and be carried along with the roof water out to the storm drain system at the street. On the back side of the house, we're backfilling with rock, crushed rock, clean 2-inch crushed rock. We're doing that because it falls almost completely compacted and because it assists with drainage. The water will fall right through it. What this means is I don't have to worry about settlement back here with just a little bit of compaction because I can't get big equipment back here. While we're doing this, in conjunction with this process, I'm scheduling and bringing back in Brian Reynolds to handle the trenching, to bring in some of the other utilities in the front. I'm moving some dirt that we saved from previously around to the other end of the house to backfill in another area that does not have to have the drainage dealt with. And in general, I'm trying to keep as many of the aspects of the last underground work going at the same time as I can. There's one underground utility that we have not dealt with, and that is sprinklers. Now there's a couple reasons for that, and the first one is we don't know what we're doing for landscape here yet. We do not have a landscaping plan. I wish we did, but we don't. Your project may be completely different than that. Your house may be situated on a lot where the existing grade of the lot is going to be essentially the final grade of your yard. And if that's the case, well then go ahead and trench in at least the main lines on your sprinkler while you've got the equipment there that's doing the rest of the heavy work. I know that I'm going to wish we'd been able to do that, but we've got a good distance to come up yet to the finished grade, like maybe a foot, and there'll be plenty of room in that 12 inches to put the sprinkler system in when we wrap this project up next spring. You've seen a lot of different pieces of equipment working on this little project, and it is a little project. But there's been equipment on here that weighs 50,000 pounds, and there's my little tractor weighs, 3,000 pounds, and mini excavators and big excavators and forklifts, and all of those different tools, earthwork tools, have a different application, a different strong suit, a different point, and a different type of work where they're efficient. And the efficiency of moving dirt has changed modern construction as much as anything, with the possible exception of, engineered building components, engineered wood products. But it is the thing that has changed the quality and the options that are available to us in construction as much as anything else. And when you put somebody in the seat of one of these machines that really knows how to own it, you're getting good value for the time that you're paying for. Even if it's expensive, you got way more work done in that period of time than any other way you could have approached the project. So with the right person in the seat and the right machine, don't be afraid to get your dirt work taken care of. If you enjoy watching heavy equipment work, and who doesn't, check out the video when we were digging this site and then placing the boulders around the retaining wall. Dexter Henry sitting in that excavator is astounding. An excavator is so useful, and somebody like Dexter takes the capacity of the machine way beyond, I think, what any of the engineers who designed it ever visualized it being capable of. In any case, heavy equipment is vital to modern construction. It's fun to watch. It's not fun to pay for, but at the end of the day, with a good operator, you will have always gotten your money's worth. Thanks for watching Essential Craftsman. And as always, keep up the good work.